Hello, everybody. Welcome to Time Series in R with Tertiary Courses. For today's lesson, we will proceed with Arima forecasting in R. Now, firstly, we need to understand what is Arima. So, Arima is a short form for Autoregressive Integrated Moving Average. It is basically a forecasting algorithm that uses the historical patterns in the past to predict future values. So as you can see, there are three major components of this algorithm: autoregression, integrated, and moving average. So these are the three essential components coming together to produce the forecasting capabilities of the model. So ARIMA basically is characterized by three key terms, which is for P, the number of lag observation, D, the number of time the raw observation difference, and Q, the size of the moving average window. So basically, the algorithm uses these three statistics found in the historical data to make its forecasting predictions. Now, Arima basically makes a couple of assumptions. It uses a smoothing time series data and assumes that the future will resemble the past. So these kind of assumptions usually are suitable for the data which is stationary, non-stationary, univariate, and normally it has certain cyclical trends and seasonality. So why is this important? First of all, many companies use it in fundamental business planning, procurement, and so forth, production. Pharmaceutical companies may use it to predict sales of a drug for the next 2 months based on the historical data for the year. In climate studies, we can use it to predict greenhouse gas concentration, weather patterns, and so on. Okay, so to find out the optimal patterns for P, Q, and D is not easy per se. Sometimes it takes a bit of trial and error. In order to gauge the accuracy of our model using the values you key in for P, Q, and D, we do use certain statistics like AIC, Alkine Information Criterion, and BIC, Bayesian Information Criterion, to compare different models created with different values of P, Q, and D. Obviously, for machine learning metrics, the lower these values are, the better. But fortunately for us, we have a function called Auto-Arima, which generates several models and chooses the lowest AIC and BIC values to that and the best combination of the P, Q, and R factor to give the lowest AIC and BIC. Now let's jump over to R Studio. Here in R Studio, I'm again going to use the same dataset air passengers. So before anything else, let me load my libraries. So as you're familiar with the air passengers dataset, we have the dataset here that we've used the last time. Okay, the same dataset as before. Starts in 1949, ends in 1960, 12 month cyclical pattern, so on and so forth. The time is here to break down the time component, and the cycle is over here, as you can see. So to get started, we'll use a simple MA function to calculate simple moving average, and we're gonna display it on the time series plot. So first of all, we plot the air passengers and we add the moving average. Now, as you can see, the order is 12, so it's more of a long-term simple moving average. And we incorporate it with a simple short-term 6-month moving average, as you can see over here by the red line and the blue line. Now we're going to go proceed ahead and use the Auto-Arima algorithm to do some prediction and to test the accuracy of a prediction. Now, first and foremost, I'm going to break up my data set into a train and test data set. First and foremost, I'm going to break out a data set from 1949 all the way to 1959. This will comprise my training data set. Secondly, I'm going to use for the test data set the last year. So this will be my test data set. So I'm going to use the data from my training data set to make prediction on the 1960 data, which is the test data set, and I'll compare it with the actual data in the data set. Okay, so I'm going to fit into the Auto-Arima algorithm the trained data set, and as you can see from the summary statistics, what's the AIC, BIC values, and there are certain summary statistics like RMSE, MAE, which are typical machine learning metrics which the algorithm uses on the trained data set itself. The P, Q, and R values are over here, as you can see. and these are the seasonality values. All right. So now I'm using the model as we have here saved into fit. I'm going to proceed ahead to predict for 11 months ahead. Okay. So what are the values by the predicted by the model? So it's simply these are the values which the model predicts will be the air passengers data for the next 12 months. Now I'm going to let you see what it looks like using a plot. As you can see down here, this is the data generated from the trained data set, and this is the what the model predicts will be the air passengers data for the next 12 months. Now I'm going to compare this with the actual data from the test data set itself. So what I'm going to do is I'm going to use this package called ML Matrix. I'm going to look at the RMSE, the predicted values here, which the model predicts, against the actual test data set, which contains the raw values from the air passengers data set. Now, what's RMSE? Is very simply 22, okay, and the R score basically around 91, which is not that bad to be honest. All right. Thank you all for watching this video. This is from Tertiary Courses. Have a nice day.